Every engineering team has this person. You know the reviewer I mean. They do not read the diff and leave looks good after 2 minutes. They notice that your auth middleware have moved. They ask what happens when the token is missing. They look for the denied path test. They run cheap focused check before they leave the commit. Most teams have one or two people like that. The problem is that their review quality does not scale. They have their own work, they have meetings, they cannot sit inside every pull request. So the team ends up with uneven review quality. Some pull requests get deep review, while some get a quick pass. Some get the review that only checks whether the CI is green. That is a cleaner way to think about today's topic, skills. I would frame the question this way. Can we capture the repeatable part of that strong reviewer's process and make it available whenever a pull request needs that level of scrutiny? A skill does not capture the reviewer. It captures the repeatable part of their review procedure. That is the job I want to talk about. In this deep dive, I want to make skills concrete. And I do not mean human skills in the generic sense. I mean the code skills, the codex style local skills, superpower skills, and the broader pattern that is showing up across the agent tools. A skill is the reusable procedure the agent harness can load when a recurring class of work shows up. Repeatability is the main point. The agent should not have to rediscover what a serious pull request review looks like every time someone asks for one. The procedure should be reusable, then adaptable to the diff in front of it. A skill might be a folder with a skill.m. It might have scripts, it might have templates, it might have examples, references, and test cases. It might even be a slash command. It can be a runbook wrapped in an agent workflow as well. So different products will package this differently. And I do not think the packaging is the important part. And so I would not focus on that in this video. When this kind of task appears, give the agent the procedure, the constraints, the tool to prefer, the examples to copy, and the checks that prove that the work actually happened. I think skills deserve their own deep dive because they take the repeated judgment and put it somewhere in the harness so that it can be used, so that the model can use it. They look simple from the outside. Sometimes they are just a markdown file, but the system role they play is much bigger than that. In practice, they are one of the ways a team starts moving review habits, release habits, writing habits, debugging habits out of someone's head into the agent setup or harness. Now, let's make that part a little more concrete with a running example. Here is the task: a pull request that changes the authentication middleware. Let's say the user asks, review this pull request before merge. Now, without a skill, that sentence is underspecified. What kind of review? Security review? Test coverage review? Maintainability review? Is it product behavior review? Regression review? Style review? You get the idea. The strong reviewer brings a lot of procedure to that sentence. They would have a pattern. They would read the pull request description. They inspect the diff. They identify the risky files. They compare the changed behavior to the existing tests. They would even run focus checks. And then they would decide whether a finding is worth blocking the pull request or not. An agent can do all of that too, but only if the harness gives it the right working procedure. Again, you might remember if you've seen the video for harness engineering, that this is where the procedure part shows up in the harness engineering, in the harness primitives. That is why pull request review works well as an example. It is relatable, it repeats, mistakes here can be expensive, and the right behavior is much bigger than the user's prompt normally. Okay, the simplest version is just a better prompt. You could write, instead of just one small word, please review this pull request carefully. Look for bugs, missing tests, risky changes, and security issues. Be concise. Now, this can help. The model now has a little more shape around the task. It is less likely to only do the summarization of the diff, but the procedure still lives in a user's head. The prompt does not know how this repository structures authentication. It does not know which test command is cheap enough to run. Nor does it know that this team only wants findings that can be backed by a file reference or a command output. And the next time someone asks for a review, they have to remember to write the careful prompt again. That is the first place when you would start noticing that repeating the prompts becomes annoying. If the same task keeps coming back and the procedure matters, prompting starts to feel like copy pasting a checklist into every conversation. The next move you might do is instructions. Maybe the repository has an agents.md, and that might say, when reviewing code, prioritize correctness, security, test coverage, and regressions. And you can say, avoid style only comments unless they block maintainability, and run focus tests when possible. Now, again, better. Now the guidance is in the environment. The user does not have to paste it every time. In the harness engineering map, this is the primitive one, instructions. Instructions shape behavior before anything else happens. They are useful, but they are also passive. They can say, follow the review convention. They cannot by themselves discover the changed files. Choose the right test command. Compare the pull request against prior auth bugs, or generate a structured review report. So instructions help the agent behave better, but they do not package the workflow. That is the limitation I would call out. The review process is no longer only guidance. It is a repeatable piece of work. Now, let's give agent tools. It can run the git diff command or pnpm test authentication or any of the many tools that it might have access to. It can read files, it can inspect the CI system, it can open the pull request description, it can search the issue tracker. And again, this is the primitive 4 in the harness map, the tool interface. Tools let the models act, and that is a big step. But tools do not answer the review question on their own. The shell does not know when to run pnpm test auth. Git diff does not know which files deserve deeper attention. And search does not know which result is important. The agent can do things, but the work still depends on whether it chooses the right things in the right order. For our pull review request, the missing piece is the review procedure, and skills add that procedure. For our pull review pull example, the skill might say, use this skill when asked to review a PR, inspect a diff, check code before merge, list out the different processes, read the description and changed files, classify the change and figure out the risk, run the cheapest focused verification command available, and so on and so forth. That is already different from review carefully. The skill writes down the way a serious review should happen. It can include examples of good finding. It can include the team's preferred output format. It can even include scripts for doing some basic stuff like fetching the PR data or running the right test subset. It can even include gotchas from prior reviews. The model still has to reason, but the harness has given it better path through the work. Now let's place this back into the harness engineering map. In the harness deep dive, I framed the harness as 10 primitives. It had instructions, context delivery, context management, tool interface, execution environment, durable state, orchestration, sub-agents, skills and procedures, and proof and learning. Skills sit at primitive 9, the skills and procedures. I like that placement because skills arrive after sub-agents. And primitive 8, sub-agent, lets the harness split work into bounded loops. One worker can explore the code base. One can verify the sources. One can review a diff. One can test the UI. But delegation creates a problem. If every worker invents its own process, you get parallel inconsistency. One review agent checks tests, another agent only summarizes, another agent comments on style, and one misses the auth boundary because it never searched the route map. Sub-agents give more workers. Skills give these workers a shared way to work. That is why I would make pull review, a PR review example, a skill first. Once the procedure exists, the main agent can use it. A review sub-agent can use it, or several specialist sub-agent can use narrower version of it. The distinction I would use is pretty simple. Skill is the procedure, sub-agent is one possible executor. If the problem is that the agent keeps inventing the process, make a skill. If the problem is that the agent needs separate context window or a narrower tool boundary or parallel execution, use a sub-agent. For PR review, the valuable, reusable thing is the review method, in which it might be read the PR, inspect the diff, find behavior changes, check nearby tests, run focused verification, and return evidence-backed findings. That is the skill in this example. Now you can choose who runs it. The main agent can load the PR review skill and do the review directly, or a review sub-agent can load the same skill and return the findings to the main agent. Or the main agent can split the work. It can send security sub-agent with a security review skill, a front-end sub-agent with a browser QA skill, test sub-agent with a test coverage skill, and main agent will integrate all these findings. The procedure is still doing the reliability work. A review sub-agent without a review skill is just a fresh model loop with a vague job. Now, there is a second placement question. In the memory deep dive, skills showed up under procedural memory. That can sound like a contradiction if you compare the two maps too literally. In the harness map, skills are primitive 9. In the memory map, skills are procedural memory. Both are true because the two videos are zooming in at different levels. The harness map asks what are the major engineering primitives around the model. From that view, I give skills their own box because the harness can discover them, choose them, load them, and run work around them. The memory map asks what kind of state survives and shapes the future work. And from that view, a skill is a procedural memory because it stores knowledge about how work should happen. So going back to our PR review example, semantic memory would have information like this repository uses authentication middleware that is in source/server/auth. The team prefers focus test before running broad test suites. Whereas the procedural memory would say, here is the PR review sequence to follow before merging. The skill is the second one in that little split. It is stored knowledge about the procedure. There is one more piece that makes this work. The skill can exist in a folder. It can have a perfect checklist. It can have scripts and examples and gotchas. None of that helps until the runtime or the harness puts the right material in front of the model. That is the context management part. In the harness map, context management is primitive 3. That includes retrieval, ranking, summarization, compaction, and context assembly. In plain English, it decides what actually lands in front of the model. For skill, the context builder has a very practical job. It sees the user's request, which says review this PR before merge. It compares the request against available skill descriptions. It decides the PR review skill is the right match. It loads the top level skill.md, maybe only the trigger and process at first. If the skill points to a deeper file, like a reference file for authentication review, the agent can pull that later when the diff actually touches the auth part. That pattern has a name, progressive loading. The harness does not need to load the whole skill folder on first run. It can start with the description, then load the main skill instructions, then pull in the deeper reference files only when the task calls for them. For the PR review skill, that means the agent does not need to have the database migration checklist when the diff only touches the authentication middleware. It can load the auth review notes when the auth change is real. I'm going to come back to the authoring side of this in a minute, because the way you structure the skill folder decides whether progressive loading actually works. The easy mistake is to treat the skill library as one big prompt. You do not want every skill and its context dumped into the prompt. You want the harness to load the right procedure at the right time and only as much as the task needs. So what should be inside a good skill? Let's continue with our example of a PR review skill. I would think about pieces like Trigger: when should the harness load this skill? Non-trigger: when should the harness avoid this skill? An example can be when someone says summarize the PR or write release notes, implement the fix. You don't want this skill to be triggered. What are the inputs? The URL to PR, the branch name maybe, local diff, changed files, copied patch. That belongs in this category of inputs. Process: the main part. Read the context, inspect the diff, classify risk, check tests, run focused verification, report findings, and preferred tools: Git diff, file reads, repo search, test runner, CI status, browser only when UI changes, output format, maybe findings first with severity, file references, evidence, and a suggested fix maybe. And again, importantly, gotchas. Do not confuse a diff summary with review. Do not report style nitpicks unless they affect the correctness. Do not claim test pass unless you actually ran and inspected them. That is enough for the basic shape. The trigger and non-trigger matter more than people expect. If the trigger is too vague, the skill never loads. And if it is too broad, the skill shows up in task where it does not belong. So a peer review skill should not activate when the user only wants a changelog summary, and it should probably step aside when a narrower browser QA or migration review skill is a better fit. The useful detail is in the boundaries, gotchas, examples, and verification. Anthropic's Claude Code makes a similar point in their June 2026 skills write-up. The useful skills are focused artifacts that capture the parts the model tends to miss: the gotchas, the setup, the scripts, the references, and the distribution path. That matches how I think about it too. If the skill only says review carefully, it is adding context without adding judgment. There is also a very practical point here. Most serious agent setups now come with a skill creator skill or something close to it. Use it. Do not start by staring at a blank skill.md file. Start by describing the workflow in natural language. In our example, that might be, I want a PR review skill. It should load when someone asks to review a pull request, inspect a diff, check code before merge. It should not load when the user only wants a summary, release notes, or implementation help. It should inspect the diff, classify risk, check nearby tests, etc. It should avoid style-only comments unless they affect the correctness, etc., etc. That is a good first input to a skill creator skill. Then you review the draft like you would review code. Is the trigger specific enough? Does it say when not to load? Does it include the tools the agent should prefer? Does it ask for verification receipts? Does it include one or more examples of good findings? And then you test it on real PRs. That is the part I would not skip. The skill creator gets you a first draft. The real work is seeing where the draft over triggers, under triggers, or misses the review behavior you actually want. Now let's come back to the authoring side of progressive loading. The mistake is making the skill too large. It is tempting to put every review rule into the main skill.md file. The security review rules, the front-end review rules, the database migration rules, API compatibility rules, test strategy, CI strategy, accessibility, performance. I can go on. You can do that, and the model may technically fit it in its context, but now the auth pull request has to compete with a giant review manual. And going back to the discussion that we had in previous videos, you are now fighting for model's attention. A better pattern is progressive disclosure. The top level skill gives the general review workflow. Then it points to files that are specific to some of the tasks we talked about earlier. A separate file for authentication review, a separate file for database migration, a separate file or a reference for front-end review. And the agent starts with the main procedure. If the diff touches auth middleware, it will open that auth review markdown file. If the diff touches a migration, it opens the database migration file. This is the point where skills and context management start working together. The skill folder is a structured context source. The context builder still has to decide which slice belong on the desk, going back to our videos earlier. Now let's compare two runs. Same PR, same model, same tools. Run 1 has no PR review skill. The agent says the PR refactors authentication middleware into a shared helper. The code is cleaner, reduces duplication, consider reading test for the helper. Now that might all of be true, but it's also very shallow. Run 2, on the other hand, loads the PR review skill. The agent follows the procedure, does all the things that we had talked about earlier. Now the finding looks like the missing token request can still pass the admin guard. Here is the file. Here is the evidence. Here is the verification, and here's what the fix might, where the fix might be. This is the kind of difference I want from a skill. It does not make the whole model all-knowing. It makes the review path less accidental. So if skills are procedures, we need to test them like procedures. And agentskills.io gives a good practical frame here. The basic evaluation loop is very simple. You create realistic test tasks. You run them without skill. We'll call it the baseline. You run them with the skill. You capture the outputs, timing, token cost, grading results. You write assertions for the objectives that it should be checking, and you use human review for judgment heavy parts. And then you iterate on the skill. For our PR review skill, an eval set might include 5 seeded pull requests, one which is authentication middleware missing denied path test. You might have another PR that you use, which is database migration that drops a label default, a front end change with a mobile overflow bug, an API response change that breaks a documented client, or a pure refactor with no behavior change. And some assertions can be objective. The review identifies the changed auth boundary. The review distinguishes blocking findings from suggestions. The review includes at least one file reference for each finding. And the review does not claim test passed unless verification evidence exists. And other parts need human judgment. Was the finding actually useful? Did it miss a real bug? Did it bury the blocker under style comments? Evals do not have to turn everything into pass or fail. They just need to make sure the skills are better than a gut feeling. Now, a skill can improve quality and still have costs. So I would measure at least 5 things. First, in our example of a PR, I would look at bug catch rate. Did the skill catch the seeded issue more often than the baseline? Remember, the baseline here is run without the skill. Second, false positive. Did it invent findings or turn harmless differences into blockers? Third, evidence quality. Did each finding include a file reference, command output, test result, or clear reasoning path? Fourth, cost. Did the skill triple the token usage for a small improvement, or did it focus the agent and save time? Fifth, trigger behavior. Did the skill load when it should? Did it stay out of unrelated tasks? The last one is easy to underestimate. A great skill that never triggers is just a document sitting on the side. A broad skill that triggers everywhere becomes noise. The skill description is part of the system. It is not the marketing copy. It should say when to use the skill, and just as importantly, when the skill is too broad for the current request. So let's talk about how skills fail. The first failure is, as we talked about earlier, over broad scope. You make one engineering skill that covers review, testing, planning, debugging, deployment, incident response, and the model sees it everywhere. Right? The skill becomes a second system prompt with too many opinions. And that's failure number one. It's over broad. The second one is under triggering. The skill is useful, but the description says something like helps with quality. The model does not connect that with the review this pull request. So the skill sits unused. Third failure is stale procedure. The repo changes from jest to vtest. The skill still tells the agent to run npm test auth. The team changes the approval rule but forgets to update the skill. And now the old procedure keeps moving forward because it sounds official. That can be dangerous as well. Now the fourth failure is context bloat. The skill loads the whole manual every time. The actual diff is 40 lines, but the model is now reading 8,000 words of review philosophy. And we have talked about this earlier as well. And fifth failure is false confidence. The skill makes the agent's work more repeatable, but it does not prove the work succeeded. That is why skill need to connect to verification. For our peer review, the skill should ask for receipts when it says to check tests, the command, the output, the CI link, or the reason verification was not possible. Skills are living artifacts, as we talked about it being stale as one of the failure mode. One useful point from Anthropic's June 2026 Claude Code skills post is that good skills often start small, then improve as the model hits edge cases. They also talk about measuring usage, spotting under triggering, and promoting skills after they get real traction. That is how I would think about it too. A skill should not start as a 40-page process manual. Start with a recurring failure, add the first gotcha, run the skill on real work. When the agent misses something, decide whether that miss belongs in the skill, in a script, a test, in the instructions, or in the product itself. Also, remember, models improve as we have seen over the last couple of months. A step that was necessary 6 months ago might become noise. Maybe the model now reads TypeScript diffs well enough without a long explanation. Maybe the old always run this command rule is now too blunt because the repo has a faster targeted runner. So maintaining a skill includes pruning the skill as well. If a skill only grows, it eventually becomes another stale context dump. Once a team starts writing skills, the next problem is ownership. At first, skills feel lightweight. Someone writes a markdown file, someone else adds a script, another person copies it to a different repository. Then you have 200 skills. Some are excellent, some are stale, some overlap, some trigger too often, some nobody owns. And you know the problems I'm talking about. And at some point, you are not just collecting markdown files anymore. You need a little operating discipline around them. You would want a registry, want owners, you would want a promotion path from experimental to shared, and you would want evals for the important ones. You would want signals about usage so the team can tell the difference between a skill nobody needs and a skill the model fails to discover. And I would want deprecation because old procedure has to leave the system at some point. For a PR review skill, the ownership model might be simple. The owner is, say, a platform engineering team. A scope is code quality and a review across product repositories. Eval set can be seeded pull request with known issues. Review cadence might be monthly or after major test runner changes. A promotion path might be local repository first, org wide after passing evals. And the deprecation might be archive if the repository moves to a different review system. That may sound heavy for a markdown file, but it feels less heavy when that markdown file can influence whether your code gets merged or not. So here is the rule of thumb I would use. Make a skill when four things are true. One, the task is repeating. So it's a repeating task. Number two, the procedure matters in this case. Number three, the mistakes are expensive if we don't do that. Number four, the right behavior is not obvious from the user's prompt. And let's take our PR review skill and qualify that. It repeats constantly. The procedure in this case matters a lot. Missing the wrong issue is expensive, and so you want that thorough procedure. And review this PR as a prompt does not contain enough detail to produce a serious review. By contrast, do not make a skill for every small preference. If the instruction is one sentence and applies globally, put it in the project instructions. If the agent needs a capability, make or expose a tool. If the work needs separation, create a sub-agent. And if the workflow repeats and the judgment matters, that's when you make a skill. That distinction keeps the harness from turning into a junk drawer. Now let's put the pieces together. For the PR review request, the harness has to assemble several layers. Instructions set the general behavior. Prioritize correctness, security, and test coverage might be an example. Context delivery brings in the PR description, diff, changed files, repository rules, and maybe CI logs. Context management decides which of these material should be visible right now. Tools let the agent inspect files, search the repository further, run tests, check CI. The execution environment decides where those commands run and what they can touch. Durable state may bring in project convention or prior review lessons. Orchestration may decide when to ask a human, when to retry, or when to stop. Sub-agents may split the review work into smaller loops with scoped context. Skills provide the pull request review procedure. Proof and learning ask for receipts and feed the misses back into the skill. That is the picture for this example. The skill is not floating by itself. It is one harness primitive connected to several others. So when an agent fails at a recurring task, I would not start by asking whether the model is smart enough. I would ask which layer ran out of road. Again, this is a repeating comment that you might have heard on our videos. The question becomes, was the instruction missing? Was the relevant PR context absent? Did context management load the wrong material? Did the agent have the right tools? Did the command run in the wrong environment? Was the memory stale? Did orchestration move too fast? Should the work have been delegated? Or was the skill missing? For skill specifically, I would make the questions even simpler. Is this a one-off request or is this a recurring workflow? If it is recurring, does the procedure matter? Can you tell whether the skill beats the baseline, which is without the skill? Who owns uh, who owns it when the repo, the model, or the workflow changes? Who is going to go back and take a look at it, update it, prune it, or remove it? At that point, the work has moved from prompt craft into harness engineering. A skill is a procedure memory that the harness can load. It is how the agent stops rediscovering the same job every time. For builders, I think the practical standard is simple. I would not ask the model to remember the workflow from vibes. Put the workflow somewhere the harness can find it, test it, and improve it. Thank you.